All right, if you want to find the speed of an object in parametric form, it's the dx dt squared plus the dy dt squared, and then take the square root of the whole thing. That's going to come up in some problems, including the one we're about to look at here. All right, so first thing they want us to do in this one is sketch the graph of what this parametric looks like. So again, let's use our graphing utility to do that here. So make sure you're in parametric form. Go to your graphing part, and then let's enter these in. So our x1 here is cosine of t. And also make sure as you're doing this that you are in radians on your calculator. It's not going to come out right. And then sine here, we got 2t on this one. All right, so once you got them in, if you, and then also make sure your window here is from 0 to 2 pi, and I got that, your t min to your t max there. If we hit graph, should see this one. There's a picture. Looks like we kind of got an infinity symbol going on here. I'm going to graph it in the decimal one, number 4. See it a little better? There we go. So that's the graph of this one. If you want to get some points, you can go to your table settings. Let's do it from 0. And we'll have our change in table be pi over 2 here. I think I got it set at. So if you graph that or go to the table, there's some points there. So it looks like the points are 1, 0, 0, 0, negative 1, 0 is 1, 0, 0 again. Looks like we're kind of going back and forth there. There is a yeah. So if you want to get some of the other values, looks like maybe we have to change our table settings a little bit. Let's change this to pi over 4 and see if we get some more values here. Go back to our table. All right, there we get some more. So yeah, at a value of 0.707, the value is y value is 1 here. 0.707, that's that approximation of 1 or square root of 2 over 2. So somewhere in here it's there. So we got a point there, point there, point there. Getting some of our, oops, sorry, be a point here, my mistake. But we do have one at negative 0.71. There's one at, there's going to be a point here and also point here. So it looks like how this goes is it goes, if you start at the first point at t equals 0, the point it starts at 1, 0. So this is our initial point. And then you can see the next one is this one, so it goes up, and then if we keep going here, the 0, 0 is the next one, so it goes down here. Then the next one's the negative 1, so it goes down here, up, down, and back. So make sure you put arrows on here showing the direction it's going. So that's the graph of this one, and the terminal point would also be actually right at the same point as the initial point here. All right, next part, once it's defined dy dx. Why don't you pause the video and try this out, see what you get. All right, let's see if you got it. You make sure you did chain rule when doing the dy dt here. So derivative sign is cosine of 2t, and then derivative inside is another 2 there. And then derivative of the dx dt would be negative sine of t. So that's what you should have had there. All right. Next part. Find all the ordered pairs where the tangent line is horizontal. So we want to take that derivative we just had. The dy dx came out to be 2 cosine 2t all over negative sine t. If you want to find out where it is horizontal, again, remember that's where numerator equals 0. So we want to set that numerator part equal to 0 to see what we get. So if you take that top part, put it equal to 0. What do we get? You can divide by 2 here, so then it's just cosine 2t equals 0. Where would that equal 0? This is something you need to be able to do without a calculator. You got to think, okay, where does cosine equal 0? On our unit circle, okay, remember any ordered pair there, that's a cosine, and then your y value is the sine. So where does x, where do you have x values that are to 0? Well, there would be two spots right here and right here. So that's 90 degrees and 180 degrees, or that that would also be in radians, pi over 2 and 3 pi over 2. So this, if we solve this, that means what angles here give us 0? Answers being what we just said, it would be pi over 2, 3 pi over 2. And then because we still have 2t here, we have to divide these by 2. So if we divided all these by 2, that would mean a t of pi over 4. The next one would be 3 pi over 4, would also work. Now, this is between 0 and 2 pi. Now, initially I stopped right here because that would take us to 2 pi, but since we have to divide by 2, I think we have to keep going here to get some other value. So if we kept going, the next one would be 5 pi over 2 and 7 pi over 2. So if we divide those, we'd also get 5 pi over 4, which is still between 0 and 2 pi, and 7 pi over 4. That's also still between 0 and 2 pi. So those would be all the different times here where we'd get tangent line equal to 0 or horizontal. If we go back to our picture, you can see there are 4 spots here that we get horizontal tangent line. Right there, right there, right there, and right there. So we should have 4 spots, and those are the 4 spots. This one would be the first one we had where the t was equal to pi over 4. So that's our pi over 4 one. The next one we would hit as we trace this, that would be this next one right here. So that was the 3 pi over 4. Coming back up, this one would be at the 5 pi over 4. And then this last one right here, that would be at a t of 7 pi over 4. All right, so that gives you an idea of that one. I want you guys to pause it and try this one. See if you can find all the ordered pairs where the tangent line is vertical. Just looking at the picture, if we go back to the picture, it looks like there's 2 spots here. You're going to have a spot here where it's horizontal or vertical, and here where it's vertical. See if you can find those t's out now. What are those 2 places? All right, let's see how you did. So if you want to find where tangent line is vertical, that's where denominator equals 0. So set denominator equals 0. Dividing by that negative just means sine is going to be equal to 0. Again, on unit circle, sine is going to be 0 any place where the y value is 0. So that would be here at 1, 0 and at negative 1, 0. And the angles for those then would be at 0 and over here at 180 degrees or pi. So those would be the two places where that would be. If we go back to our picture here, remember this is our initial spot. So yeah, at t equals 0, we got that. And then this point right over here, that would be where t equals pi. Now, they did on the last 2 problems, and we probably should have answered the question. What are those points? And remember, to find those, you got to plug them back in. So at the t equals 0 one, if you plug cosine of 0 is 1, and sine of 0 is going to be 0, so that was that point. At the one at t equals pi, if you plug that one in, cosine of pi is negative 1, and sine of 2 pi is the same as sine of 0, which is 0. If we go back to the last one, I think we forgot to find the ordered pair part, but if you plug these ones in at a t of pi over 4, cosine of pi over 4, that's like cosine of 45 degrees. So if you think of that triangle on here, if you got 45 degrees, that means that's 1, that's square root of 2 over 2, that's square root of 2 over 2. And so this point would be square root of 2 over 2. And if you do pi over 4 in for this one, that's going to be the same as sine of pi over 2. And sine of pi over 2 would end up being our y value at 90 degrees, which would be right here, which we know would be 1. So that would be the point there. Going out, just using the symmetry of this then, at t of 3 pi over 4, then that was our next point. That was negative square root of 2 over 2, negative 1. Our next one was at 5 pi over 4. That was in the second quadrant, so that one was going to be negative square root of 2 over 2, positive 1. And then our last one was in the fourth quadrant, so at 7 pi over 4. That one would be positive square root of 2 over 2, but negative 1. So those were the ordered pairs there. All right, one last part to this one. Given the same equations, find the speed. So here's where that speed comes in. To get this one, we want to do what's the square root of dx dt squared plus dy dt squared. Okay, so we already know what those derivatives are. Our derivative of the dx dt one came out to be negative sine of t squared. And then our derivative for dy dt comes out to be 2 cosine 2t squared. So now we want to put our t value in there, which is pi over 4. So let's see what we get here. This is going to come out to be negative sine of pi over 4 squared. And this would be 2 cosine of 2 times pi over 4 squared. I'm going to simplify this. 2 pi over 4 is going to end up being the same as just pi over 2. All right, so now we got to find those values out. Sine of pi over 2, or pi over 4, think that 45, 45, 90 triangle again. That's going to be square root 2 over 2 over 1. So this, and with the negative sign it makes it negative, but it's not going to matter anyway because we're going to square it. Plus cosine pi over 2, that's at 90 degrees. The cosine value there is going to be 0. And so going through here, looks like we get something, 0 squared is just 0, so it's just going to, and we square this, it's going to be positive now. The bottom squared is 4. If we square the top, square root of 2 squared is just going to be 2. And so we got square root of half here, which is same as square root of 1 over square root of 2. So we get 1 over the square root of 2 for our answer, or that would be the same as square root of 2 over 2. So that would be the speed for this one, and whatever the units would be on this particular one. All right, let's have you try one of these speed ones, see if you can pause it and find the speed at pi over 2. All right, let's see what you got here. So we know our derivatives again. If you plug in this time pi over 2, we got to find out what sine of pi over 2. That's the y value at 90 degrees, which would be positive 1, but it is negative here, so it ends up being overall negative 1. Here we got to find what's cosine of 2 times pi over 2. Well, those 2's cancel, so it's what's cosine of pi. That's the x value at 180 degrees, which would be negative 1. Negative 1. So timesing by 2 would be negative 2. Negative 2 squared is 4. Negative 1 squared is 1. Add that together. Answer should come out to be square root of 5 would be the speed in whatever units this might be looking at.